Hey kiddos, today we're going to be talking about graphing. It's our introduction to graphing points. We're going to be talking about three different skills today. Your first skill is going to be graphing points. The second skill is going to be identifying the coordinates of points that have already been graphed. And your third skill is going to be identifying whether or not a point is actually on a graph given the equation. Okay, so let's go ahead and get started with graphing. So just a review talking about how do we graph points. And remember that on a coordinate plane, you have your four quadrants. When we graph, we are going to be going in two different directions, depending on the coordinates that we are giving. Now, your x-axis is the one that goes left and right. That is right here. Your y-axis is the one that goes up and down, and that is right here. So first, we go in alphabetical order. So we're either going to go left or right, depending on the value of x. Okay, so if x is negative, we go to the left. If x is positive, we go to the right. Then we go up or down. If y is positive, we go up. If y is negative, we go down. So graphing points is really, really simple as long as you remember that we are going in alphabetical order. So x first, then y, which means you go left or right first, and then up or down second. Okay, so let's look at some examples of that. So here are 4 points that we're going to graph. Now when you graph, you always start at the origin. So this is kind of our home base. We're always going to come back to this 0, 0. So to graph our first point A, remember that x is first and then y. We have positive 3 and positive 5, which means I'm going to go 3 to the right. So we can use little squiggles if we need to. 1, 2, 3. And then we have to go up 5. 1, 2, 3, 4, 5. And this is where our point is. Okay, so this is point A. Now for point B, we're going to go again starting at the origin. Point B is negative 6, positive 4. So we're going 6 to the left, and we're going 4 up. And this is point B. Again, because x is negative, we go 6 to the left. Because y is positive, we go up 4. Okay, now we return to our home base, return to the origin. Point C is negative 3, negative 2. So negative 3 means I go negative 3 spaces to the left. And negative 2 means I go down 2. And here is point C. So again, negative 3 to the left, negative 2 down. Okay. Our next point, D, is positive 5, negative 4. So positive 5, going back to our origin, means I go right 5, and then I go down 4. Because 4 is negative, that means y is negative. Okay. So again, positive 5 means I go 5 to the right. Negative 4 means I go down 4. And that is how you graph points when you are given coordinates. Okay. Now, second skill is the points are already on the graph, and we have to identify what their coordinates are. So let's go ahead and name these. We're going to call this top one A. Let's call this middle one B, and we'll call this lowest one C. Okay, now remember, your origin is your starting point. It's your home base, 0, 0. And all of your movement is based on what you're doing to get from the origin to the point. So to get to point A, if I was giving someone directions, telling them how to get to that point, I would tell them, starting from 0, 0, you're going to go 2 to the right, and you're going to go up 3. So remember, we always give directions in X, comma Y, alphabetical order. So we tell them left and right first, and then up or down. So we would go right 2 and up 3. 2, comma 3. Okay, B If I was giving someone directions from the origin from 0, 0 to get to B, they wouldn't have to go left or right because they're staying at 0. They would just go up 1. So they would go 0 and then up 1. Again, the 0 indicates that they did not move left or right. They stayed at the origin, and all they did was move up 1. Okay? Now, directions to C. If I was starting at 0, 0 and I wanted someone to walk to point C, I would tell them to go left 4 and then down 3. Left 4, which is -4, and then down 3, which is -3. So that's the easiest way to think about these. If you think about them as sets of directions that you're telling someone to get to a certain point, you just have to remember the order that we give directions in is we start by giving them the left or right direction and then the up or down direction. Okay, those are our first two skills. Our last skill is identifying whether or not a point lies on a graph. So if you're given a picture of a graph, this is actually a super, super easy skill. So for example, here is the point 2, 3, and we want to know if it's on this graph of a quadratic, if it's on this parabola. So we have x is 2 and y is 3. So again, starting at the origin, we go 2 to the right, and then we go up 3. Now, seeing where that point lies, it's literally on the curve. So that means that, yes, this point is on the graph. 2, 3 is on the curve. It's on this quadratic. So whatever the graph is, whatever the function is for this graph, 2, 3 is a point that would satisfy that equation. It's a point on the curve. Okay? Now, we could easily do this with another point. So is the point 5, 7 on the graph. Now, 5 is x, 7 is y. So starting at our origin, we go right 5, and we're going to go up 7. Okay, and see that point does not fall on the actual curve. It's not on the blue curve. It's inside the curve, but that means it's not on the graph. So the answer would be no. Okay. 5, 7 is not on the graph because that point does not lie on the curve. Now, when you're not given a picture of a graph, this is a little more complicated, but it's really not too bad. It relies on our ability to plug in values for x and y. So if you are not given a graph, you're just given the equation, you're going to simply plug in values for x and y. And when you plug those values in, if the equation makes sense, if it's true, then yes, the point's on the graph. If the equation does not make sense, it's false, and the point is not on the graph. So let's look at a couple examples. Okay. Example 1 is the point 0, 7 on the graph of the equation y equals 5x plus 7. 0, 7 is your point, that's x and y. So what I like to do is just write out my values just so I'm sure I know what I'm plugging in. So for x, I'm plugging in 0. For y, I'm plugging in 7. That means that my y value and my x value in this equation are going to switch out. I'm going to plug in different values. So for y, I plug in 7 equals 5. Instead of x, I'm plugging in 0. Remember, we put that in parentheses so it doesn't look like 50. And then I bring down the plus 7. Okay. 5 times 0 is just 0, so that cancels out. And I have 7 equals 7. Now, that makes sense. 7 does equal 7. So my answer would be yes. Okay. Again, we always have to interpret what the answer means. 0, 7 is a point that is on the graph of y equals 5x plus 7. That's what that means. That if we were to graph y equals 5x plus 7, 0, 7 would be somewhere on that graph. Okay, let's look at another example. Here is the point 3, 10 on the graph of the equation y equals 10x plus 6. Remember, 3, 10 is your x and y value. So x is 3, y is 10. We're going to plug those values in here. Instead of y, 10 equals 10. Instead of x, I'm plugging in 3, and then plus 6. Now let's work out the math. 10 equals 10 times 3 gives us 30, plus 6. I can already tell this is not going right. 10 equals 36. Now, that does not make sense. 10 does not equal 36, so our answer is no. And again, interpreting what that means, if we were to graph y equals 10x plus 6, 3, 10 would not be on that graph. Okay. Let's switch up what the equation looks like. Here we're going to be working with a different version of a linear equation. Is 2, 4 on the graph of 5x minus 2y equals 2. So again, just because the equation looks different doesn't mean our process changes at all. The point is 2, 4. So x is 2, y is 4. I'm going to be plugging those values in for x and y. So 5, instead of x, I'm multiplying by 2. Minus 2, instead of y, I'm multiplying by 4. Does that equal 2? That is our question. 5 times 2 is 10. Negative 2 times 4 is negative 8. And yes, 10 minus 8 is 2. And that does equal 2. So because this makes sense, because 2 does equal 2, when I plug in that point, the answer is yes. The point 2, 4 would be on the graph 5x minus 2y equals 2. Okay, we have one more example. This time we're going to look at a different graph. We're going to look at a quadratic. So we have our point 3, 16. Is it on the graph of y equals x squared plus 2x plus 1? Now just because, again, the equation looks different doesn't mean the process changes at all. X here is 3, y is 16, and we're going to be plugging those values in. So y is 16. Instead of x, I'm plugging in 3 squared plus 2. Again, instead of x, plug in 3 plus 1. So 16 equals, I'm going to clean that up a little bit. There you go. 3 squared means 3 times 3, that's 9. 2 times 3 is 6. That plus 1 just comes down. 16 equals 9 plus 6 is 15 plus 1 is 16. And that makes sense. Because 16 equals 16, that makes sense? Yes. If I were to graph y equals x squared plus 2x plus 1, 3, 16 would be somewhere on that graph. Okay, those are our 3 skills for today. Again, our first skill was graphing a point. Our second skill was identifying the coordinates of a point that's already been graphed. And then our last skill was identifying whether or not a point is on the graph.